All right, so next in 7.2, we have to do something called prove the converse, which is just fancy for you have to decide, is it a right triangle or not? Can you prove that it's a right triangle? So explain if the triangle with the given side lengths is a right triangle. That's what you're doing. You're proving the converse. You're proving to say, yep, it's a right triangle, or nope, it's not. So in order to do that, you're going to take a squared plus b squared equals c squared, okay? You obviously know that these are the legs, and you know that c is the hypotenuse. And you have to remember that the hypotenuse is the longest side. So that's going to be important information for you today. So they will give you something like this. They'll say, I have a triangle with sides 18 centimeters, 24 centimeters, and 30 centimeters. And I need to know, is it a right triangle or not? So what you're going to do is you're going to look at those measurements. You can see 18 centimeters, you can see 24 centimeters, you can see 30 centimeters. So I have to find which one are the legs. Well, the longest side you know is the hypotenuse. We just talked about that. So that means 18 and 24 are the legs, and that makes 30 the hypotenuse. And so what you're going to do is you're going to either I like to draw a picture or plug it in. I usually am a big picture person. I like to see it. So that means you've got 18 here, you have 24 here, and you have 30 here. So now you're going to plug it in, and you'd have 18 squared plus 24 squared equals 30 squared. And you're going to go ahead and solve. So 18 squared, put it in your calculator, 324, plus 24 squared, put it in your calculator, 576, equals 30 squared, which is 900. Okay, so you squared all those numbers. Next, we're going to actually add 324 plus 576. That's what it says to do. When I add 324 plus 576, I come up with 900. And a plus b has to equal, according to the formula, c squared. So a squared plus b squared has to equal c squared. Well, I have 900 and I have 900. Are they equal? Yep. So you would say, yes, it is a right. And I'm just going to use triangle symbol just to kind of shorten it up. Now, in order to prove it, because that's what it says, you need to prove the converse, I would expect to see all of this work. So I'd expect to see 900 equals 900. I'd expect to see, yes, it's a right triangle, and, the work involved to do that. So here we go. Number 2. A triangle, and I'm just abbreviating triangle just to make it quicker, with sides 14, 15, and 13. So I didn't write it all out just to make it a little bit easier. So again, you have to hunt and look for the longest side. Well, the longest side is right here, 15. So that is the hypotenuse. That makes 13 and 14 the legs. You can, of course, draw yourself a little picture to kind of picture it. So 13, 14, and then this would be 15. So you're going to plug it in. 13 squared plus 14 squared equals 15 squared. So 13 squared is 169. 14 squared is 196. I flip-flop those numbers. Sorry about that. And 15 squared is 225. So 196 plus 169 is 365. Does that equal 225? And, geez, I'm struggling. 225. There we go. Are they equal? No. So you put a slash through the equal sign. I needed to see this proof right here. That's part of it. And you would say, no, it is not a right triangle. And I just abbreviated right. But I'd like to see all of that work. Okay, so that's what you're doing, proving the converse. Now, there is another little part that I want to talk about, and this is kind of an error analysis with this kind of proof, or kind of looking at their work and saying, what did they do wrong? So kind of taking Pythagorean theorem up a notch. So they'll give you this triangle. And they might say, here's my right angle. I've got a 3, I've got a 4, and I've got a 5. and they show some work, like 3 squared plus 5 squared equals 4 squared, and they're going to ask you, what did they do wrong? What did they do wrong? And so you look, these are both legs right here, the 3 and the 4. The 5 is the hypotenuse. So here is the 5, the hypotenuse. Is that where the 5 belongs? And it's not. The biggest number is the hypotenuse. So they need, so this is what you would write. They need the biggest number, which in this case is 5, for the hypotenuse. And they didn't do that correctly. So it should be, and I love that you would tell me what it should be, so then I know specifically, you know what you're doing. So 3 squared plus 4 squared equals 5 squared. By the way, that 3, 4, 5 is the most popular Pythagorean theorem right triangle. So it's the famous one, 3, 4, 5. It's what everybody knows. So if you see a 3, 4, 5 and you were having to prove like maybe a 3, 4, 5, you know automatically it's going to be a right triangle because it is the most famous. Okay? So how about one more, number 4? What if they give you this right triangle? They say 12, they say 9, 15, and then they say 12 plus 9 equals 15. What did they do wrong? So now you're looking and you're like, well, if I look, this is the hypotenuse, and indeed they have the hypotenuse. And here, these are the legs, and indeed they have the correct legs. So you got to look a little further. What did they do? I hope you're yelling at me and saying, Mrs. Smith, they missed the squares, because that's exactly what they did. They needed to square. They forgot to square each number. So there you have it. That's what they did wrong. All right, so prove its converse. So prove if it's a right triangle, and also explain what they did wrong.